Question 7, it says in the diagram below, O is the center of the circle. Okay, so we have a center. SR is 40 centimeters. So this whole line over here, that whole line is 40. Okay, and then OT is perpendicular to SR. Okay, so because this line is perpendicular, so there's the 90, we know that this is then equal to that. We have to write that down. It is also given that UT is X. So UT is X, I see that. And OU is 2X. Okay. Determine 7.1.1, the length of OR in terms of X. So the length of OR in terms of X. OR is a radius. It comes from the center to the circumference. And I see another radius from O to T. And if you look at OT, OT consists of 2x plus x. Isn't that 3x? So if OT is 3x and it's a radius, then OR is also 3x because that's a radius. So that's for 1 mark, eh? 7.1.1, OR is 3x. Radii. Okay, and that's for 1 mark. Next question, 7.1.2. Determine the value of x, leaving your answer in simplest surd form. Eh? So now we have to solve for x. Okay, to solve for x, I need to set up an equation. So normally with these questions, we're going to use Pythagoras. So first I'm going to say this is equal to that. So let me just write that down. Eh? SU is equal to UR. Why? Because line from center is perpendicular to chord. Eh? So when the 90 is given, line from center perpendicular to chord. So that means SU is 20 centimeters and UR is also 20. So SU is 20 and UR is also 20 units or centimeters. Eh? We know that OR is 3x. So we can work in triangle OUR. We can work in this triangle over there. So let's write down. In that triangle, OR squared is equal to OU squared plus UR squared, Pythag. Let's see if we can fill in. So this is 3x squared is equal to OU is 2x squared. UR is 20 squared. Okay, so let's see if we can solve for x using this. 3x squared is 9x squared. 2x squared is 4x squared. 20 squared is 400. Okay, I'm going to bring this over. So this is now 9 minus 4 equals 400. This gives me 5x squared. Then divide both sides by 5. I get my x squared to be 80. And then square root to get rid of the square. X is the square root of 80. But they want the answer in simplest surd form, not decimal. Eh? So you can do this on your calculator. It will give you 4 root 5. And that is the answer to this question. Okay, so you had to come up with your own equation. Eh? So let's see how they mark this question. So for saying this is 20 and for the reason, that's a mark. Then for using Pythagoras and substituting, that's a mark. Then for simplifying all of that, that's a mark. And then for your answer. And that was a 5-mark question. Okay, our next question is 7.2. 7.2 says, in the diagram below, O is the center of the circle. And A, B, C, D are points on the circumference. So A, B, C, D. A, B, C, and D. 4 points on the circumference. So that's a cyclic quad, eh? And OD is parallel to AB. Okay, we see that. And then angle OBA is 54 degrees. OBA. So that angle there is 54 degrees. Okay, let's start with the questions. Determine the size of angle A2. So A2 is over there. Okay, so the first thing I can do is, if I look at this 54 over here, if I start with that because that was given, I see alternating angles here. Eh? So let's highlight. There's the Z. So I see alternating angles. So if this is 54, then one here is also 54. Alternating angles. Eh? Do you see the Z there? So I can write that down. So I'm going to write 7.2.1. 01 is 54. Alt angles. Which lines are parallel? So just take it from there. OD is parallel to AB. The first thing I notice is that this angle O1 that we worked out is at the center. Eh? So this is at the center, that angle over there. So we have this theorem that says, if you have a circle, that the angle at the center is twice the angle at the circumference. Normally, it looks like that. But it can also look like that. Then this is the center. So let's make this AB. So AB goes to the center, but A and B also goes to the circumference. So this one is twice the size of that one. So do you see, I see something similar in this triangle. So if I highlight D and B goes to the center, but D and B also goes to the circumference. Look there, A is on the circumference. So that means the center is twice the size of the circumference. Okay, so therefore, angle A2 is half of 54, eh? So that's 27. And our reason, angle at center twice angle at circumference. And there we solved it. Okay, next question. Calculate the size of angle C. So angle C is over here. So do you remember I said A, B, C, D are points on the circumference? So A, B, C, D. Remember I said that is a cyclic quad, eh? So let's try and highlight this. A to B to C to D back to A. All those 4 points are on the circumference. So that's a cyclic quad. And we know that the opposite angles, so this one plus that one, they equal to 180. So I'm going to write here 7.2.2. Angle C plus 27 must give me 180. Opposite angles of a cyclic quad. So angle C is 180 minus 27. So I get angle C to be, angle C is 153 degrees. So let's put that in. So angle C is 153. Okay, next question, 7.2.3 says, prove that DA bisects OAB. So prove that the line DA will cut angle OAB in half. So angle OAB is this whole angle. So we have to prove that DA, that line. So DA is this line. So DA is this line. We have to prove that that line cuts that angle in half. So if this part is 27, we have to prove that A1 is also 27. So then it cuts that angle in half. Okay, so let's write down our plan is to prove that angle A1 is 27. Let's see if we can prove that. Let's write down 7.2.3. Okay, so let's see. There's many ways to do these questions. But if you look here, this, do you see this triangle over here? So this triangle over here. That triangle is an isosceles triangle because that's a radius and that's a radius. So the base angles are the same. So if this angle is 54, then this whole angle here is also 54. So I'm going to write down the whole of angle A is definitely 54 because of angles opposite equal sides, or you can say radii. Eh? So if you take out that, if this is 54, then this whole angle is 54. But this angle over here consists of A1 plus A2. So this angle here is A1 plus A2. So A1 plus A2 is 54. But we already proved that A2 is 27. So this A2 is 27. So A1 is 54 minus 27, which is also 27. So there's our plan. We proved that A1 is also 27. Therefore, the line DA bisects the angle OAB.